Hi there, this lesson is on arithmetic and geometric sequences. This is lesson B. First we take a look at the formula sheet, and this is what you'll see. You're going to be given arithmetic sequence and this function rule, and the geometric sequence with the exponential function rule. So think about, what could you tell me about these two sequences? If you were taking your MCA test, what might you write on the formula sheet? Maybe you'd want to add that an arithmetic sequence is adding or subtracting. The pattern has to be a constant, add or subtract to be arithmetic. A geometric sequence would be a constant multiply or division pattern. We also talked about here that this is a linear function and that it makes a straight line. So the line could have a positive slope, a negative slope. It could have a zero or undefined slope as well. A geometric sequence has this function rule. This is an exponential function. And it has either a growth curve going up or it has a decay curve coming down. So those might be a couple things you'd want to add on to your formula sheet. The other thing might be just labeling that m is the slope and b is the y-intercept of a linear function. You might also want to add the parts of the geometric function. Maybe you'd want to add that the letter A, the first letter, the first number here, is where the function starts, the y-intercept. Maybe you'd want to add that B is the factor of change. What are you multiplying by? Okay, just a few things to think about when you take the MCA test. Today we're going to be taking a look at some arithmetic and geometric sequences. And I'm going to ask you to write either a linear or an exponential function for them. The first one we'll take a look here at is example number 1. It says to identify the correct form of the following sequence, given here, when x is 0, 1, 2, 3, and 4. So what that means is when they made the sequence, they plugged in x, they plugged in 0 for x to get this term, 1 for x to get this term, and so on. So if I were to make a table out of the sequence, they had plugged in 0 for x to get the first term, and then they plugged in 1 to get the next term, and 2 and 3 and so on. So this is important here to set up my table. Now remember, this is x and this is y. So if I'm going to make a function rule and pick one of these function rules, I'm going to have to take a look to see what the pattern is. So if you look at the numbers, you're going to see that the pattern is subtracting 12 each time, which means it's linear. And you notice that all of the equations are linear, y equals mx plus b. So it looks like our function starts when x is 0. So if we write the function rule, y equals negative 12 is our constant pattern. See, this is going up by 1, so negative 12 is our slope, and our intercept is 17. So this would be our equation, and it looks like that matches up with answer D. On number 2, now we're given this sequence. Just by looking at the answer choices, you can probably guess that it's going to be geometric, being that all of the sequence or all of the equations are exponential. So notice that this sequence was created by using x equals 0 to get this term, x equals 1 to get this term, and so on. So if I make a table out of the given sequence, first x was plugged in with a 0 to get this term, and then 1, and then 2, and then 3. Okay? Now again, remember the top here's x, and the bottom here's y. So if I look at the pattern in the numbers, I can see that it's a constant multiplying by 5 pattern. So if I was going to write the function rule, it would be geometric. The function starts when x is 0, which is 3. There's the start. And the pattern is to multiply by 5, and that goes here. Now if you look at your function rules that are given, it looks like that matches up with answer A. All right, number 3. Here's the sequence that we're given. Identify the correct form of the following sequence when x is 1, 2, 3, 4. Do you see how this is different? This time, this sequence was created by plugging 1 in for x to get this term, 2 in for x to get this term. So if I create a table, when x is 1, I get 13. When x is 2, I get 21. And when x is 3, I get 29, and so on. Now let's come up with a function rule. I first want to recognize the pattern in the numbers. How are we increasing? And if you notice here, we're adding 8 every single time. This is linear, and all of our choices are linear. But remember, when you're making a linear function, not only do you need to know the pattern of plus 8, that's your slope, but you also need to know when the function starts, or the y-intercept, and that's when x is 0. So I'm going to have to go back here in my pattern and figure out where does it start. So if the pattern is to add 8, let's go back 8, and I would have 5. And there's my function. Looks like that matches up with answer B. Number 4. Identify the correct form of the following sequence. Here it is. Again, here when x is 1, 2, 3, and 4. So let's make a table. When x is 1, this is the first term. When x is 2, 3, and 4. Looks like our answer choices are all exponential, so this is going to be a geometric sequence. If you look at the numbers and if you try using your calculator, you'll see that this is multiplying by 6 each time. So let's write our function rule. Okay. We're going to have to go back to the 0 because we know that this is the y-intercept when x is 0. So I'm going to go back to the 0. Now remember, the pattern is multiply by 6. If I work my way down, if I work my way back here, this is divide by 6, divide by 6, divide by 6, and I have to divide by 6 again. Well, what is 3 divided by 6? 3 divided by 6 is equal to 1/2. So this would be 1/2. Now if I look here and take 1/2 and multiply it by 6, it's 3. You can check your calculator. So the function starts at 1/2, and if it's multiplying by 6 each time, the 6 goes here. And there's our function rule. Looks like that matches up with answer choice C. All right, number 5. Here's the sequence. It looks like they tell us x is 1, 2, 3, and 4. So this sequence was made by plugging in 1 for x, 2, 3, and 4. Well, let's figure out the pattern. Looks like the numbers are getting bigger or closer to 0. If a calculator helps you, that works. You can do a calculator as well. So you might be thinking, because they're getting bigger, that you're adding. Are you doing a constant addition? Doesn't look like that. Well, then let's check multiplication or division. What about to get from 36 to 12? Or from 12 to 4? Isn't that dividing by 3? Sure, divide by 3. Now divide by 3 again. I bet if you tried your calculator, 108 divided by 3 is going to get you 36. So it looks like we're dividing by 3. So this is geometric. Let's get ready to write our function rule. Where does the function start? Well, we have to go back to the 0. Well, if this pattern is to divide by 3, how would I go backward? I'd have to multiply by 3. Negative 4 times 3 times 3 times 3, and then you can use your calculator to multiply by 3. But look at your answer choices for this number. You either have negative 108 or negative 324. I'm guessing when we multiply by 3 that we're going to get negative 324. Now right here, this is the factor of change. Do you see how it's dividing by 3? If I put a 3 in here, it's going to look like I'm multiplying by 3 or it's tripling. Remember, this is constant multiplication. So even though I see divide by 3, it's the same as multiplying by 1/3. So now let's look at our answer choices. Looks like the best answer choice would be answer C. Now in class, we tried numbers 6 through 9 with a partner. Maybe you want to try numbers 6 through 9 in the notes, pause the video, and then you can watch the video and see if you're right. All right, let's take a look and see how you did. On number 6, I took the sequence and I wrote it out. Then I followed here, it says when x is 0, 1, 2, and 3. So I said x is 0, 1, 2, and 3 in my table. And this is the sequence that was made. Let's write the function rule. It's going to be linear. If you notice, the pattern here is to subtract 3 every single time. So minus 3x, this is your slope, right? And now where does the function start? It starts at 11. So it looks like the answer is A. With number 7, I took x's 1, 2, 3, and 4, and then I put the sequence right here. Now if I take a look at the pattern, I see that we're multiplying by 4, so geometric. If I'm multiplying by 4 each time, the 4 goes here. Now I have to go back to where the function starts. So back to 0. If I'm multiplying by 4, what do I multiply by 4 to get 8? Well, that would be 2. So 2. Now let's take a look at the answer choices. Looks like A is the best choice. All right. Number 8. I took the sequence, I wrote it down, and then it says when x is 1, 2, 3, 4. So 1, 2, 3, 4. Now I look at the sequence, and I can see that we're multiplying by 4. So it's geometric. If I'm multiplying by 4 every time, that's my factor of change. Multiply by 4. Where does the function start? Go back to the 0. If this is multiply by 4, to go backward in this sequence, I divide by 4. Divide by 4, divide by 4, divide by 4. Now what's 3 divided by 4? Well, 3 divided by 4 is 3/4. 3 divided by 4. So it looks like that answer would be C. Number 9. Here's my sequence. X is 1, 2, 3, and 4. So looking here, I'm getting less and less and less. I'm subtracting 4, subtracting 4. That's linear. This constant changes the slope, so I put -4 here by the slope. Where does the function start? Go back to 0. If it's minusing 4, I have to add 4 to get back here, and that would be 1. So plus 1. Answer would be D. Well, how did you do? All right, let's continue. All right, we have just 2 more. Number 10, let's write a function rule for each pattern that we see. I have 2 different patterns. I have a set of figures here and a set of figures here. We can just name this is figure 1, figure 2, and figure 3. Let's count how many little pluses, I guess these are kind of like little plus signs, how many little plus signs we see in the figure. Here it looks like there are 2 plus signs, here there are 4, and here there are 8. Just kidding, I guess I can't count today. 1, 2, 3, 4, 5, 6. 6! Okay. So if I create a table from what I have here, I can say that figure 1 has 2 plus signs in it, figure 2 has 4 plus signs, and figure 3 has 6 plus signs. So again, always thinking of this as X and Y. Now let's write a function rule for the pattern. It's always easier to write a function rule if you put your information in a table. So let's take a look at the pattern. What's the change in Y? It looks like it's a constant adding pattern. Up here, change in X is a constant adding pattern also, right? So it looks like this is going to be linear. And to write a linear function, it's Y equals mx plus b. Well, we know that our pattern is our slope, and that's plus 2 over 1. That's 2. And this is our intercept. Well, we're going to have to go back to when x is 0. So if I go back to when x is 0, what would y be? Well, if this is plus 2, and you go backward, this would be 0 as well. So the rule would be y equals 2 times x. That's linear. Now let's take a look at the second pattern. Here in the second pattern, in figure 1, there's 1 plus sign. In figure 2, there are 4. And let's see if I can count. In this next figure, it looks like I have 4 by 4, and 4 by 4 is 16. So here's my pattern, 1 to 4 to 16. And you might notice that this is multiplying by 4 each time. Well, that's a geometric sequence. So maybe I could start by writing a table. In figure 1, there's 1 plus sign. In figure 2, there are 4. And in figure 3, there are 16. Now let's use this to help us write a function rule. I can see that the pattern is a constant multiply by 4. So we have a geometric sequence, which means we're going to have an exponential function. So where does the function start? Let's go back to 0, when x is 0. If this is multiplying by 4, then I divide by 4. Divide by 4, divide by 4. What's 1 divided by 4? Yep, 1 divided by 4 is 1/4. So 1/4. And now what's happening each time? We're multiplying by 4. So I write 4 right here. Multiply by 4. So there I have function rules for like a pattern, a picture. I have a linear, and then I have an exponential. All right, last one, number 11. Let's write a function rule that models this growth. So it looks like the first figure has one, maybe a circle in it. The second figure here looks like has 2. So it almost looked like it doubled here. Oh, it looks like it's going to double again. Here this has 4, and it doubles again. Here I have 8. So here's my sequence. Well, taking a look at the sequence, we jump from 1 to 2, from 2 to 4, and from 4 to 8. So it looks like that's doubling or multiplying by 2. I can make a table as well. Figure 1 has 1 circle. Figure 2, 3, and 4. I know my pattern is to double. So doubling or multiplying by 2 is geometric. So I'm getting my exponential function ready. If I'm doubling, I'm multiplying by 2. 2 goes right here. Now I need to know where the function starts. Let's go back to when x is 0. So if this is multiplying by 2, then we divide by 2. Divide by 2, divide by 2, divide by 2, and 1 divided by 2. 1 divided by 2 is 1/2. So 1/2 would be my y-intercept. And there's my function rule. I hope that this video helped. Have a great day.